Somewhere in the dark cradle of human origins, a change occurred that would forever alter the trajectory of our species. Not a physical adaptation like opposable thumbs or upright walking, but something more subtle. Something we might call the dawn of desire. Imagine standing at the entrance of a cave 250,000 years ago. The air smells of smoke and earth. Shadows dance across stone walls as figures move around a small fire. These are not quite modern humans, but they're no longer just primitive hominids either. They are caught in between, in the liminal space of becoming. And within their developing brains, something remarkable is happening. The basic instinct for reproduction is transforming into something more complex. Something we might recognize as attraction. But why? What evolutionary advantage could have possibly come from complicating a biological imperative that had functioned perfectly well for millions of years? What invisible force guided this shift from simple mating to the intricate dance of human desire? This is the paradox we'll explore together. How did the complex emotional landscape of human attraction emerge from the utilitarian simplicity of survival? And more importantly, how did this change everything about what it means to be human? The fossilized bones tell us when we stood upright. Stone tools reveal when we began shaping our environment. Cave paintings show when we developed symbolic thinking. But what physical evidence could possibly reveal when we first felt the flutter of attraction? When did a glance across a firelit cave become more than just recognition of a potential mate? When did selection for reproduction become intertwined with preference, with yearning, with desire? And how did this shift change our evolutionary path? The question seems impossible to answer. How do we find evidence for something as ephemeral as the birth of desire? How do we date the emergence of attraction? Yet surprisingly, clues exist, scattered across disciplines from paleoanthropology to cognitive archaeology. Recent discoveries in evolutionary psychology, genetic analysis, and archaeological findings have begun to paint a picture of this crucial transition. A moment when our ancestors crossed a threshold from instinct to emotion, when survival behaviors became entwined with choice. Tonight, we'll explore how the emergence of complex desire systems may have been the catalyst that propelled our species from merely surviving to creating culture. From reproduction to romance, from instinct to intention, from biology to humanity. The evidence suggests this transformation began approximately 250,000 years ago, a time when multiple human species coexisted on Earth. When Neanderthals thrived in Europe, Homo erectus lingered in Asia, and early Homo sapiens were emerging in Africa. What changed during this period? What conditions allowed for, or perhaps demanded, a more sophisticated system of attraction and partner selection? And how did this emerging capacity for desire shape everything that followed? The fossil record can't tell us when the first human felt attraction, but it can reveal changes in brain structure, social organization, and material culture that coincide with this critical transition. Together, these pieces form a compelling hypothesis. Consider the implications. If desire shaped humanity, then understanding its origins might help us understand ourselves on a fundamental level. Our relationships, our art, our conflicts, our cooperation, all potentially flowing from this ancient transformation. We'll begin by examining the environmental pressures of the Middle Pleistocene, a time of dramatic climate fluctuation. We'll explore how these challenges may have selected for new forms of social bonding and mate selection beyond mere reproductive capability. We'll analyze the archaeological evidence for changing social structures, from family bands to larger cooperative communities that would have reshaped the context for attraction and partnership, creating new criteria for what made someone desirable. We'll consider the cognitive revolution and the emergence of symbolic thinking, how the ability to conceptualize and communicate abstract ideas might have transformed mating behaviors into something we would recognize as attraction. And we'll examine controversial genetic evidence suggesting that selection for certain social and emotional traits accelerated precisely during this period. Traits that would facilitate the complex dance of human courtship, pair bonding, and cooperative child rearing. This journey will take us from ancient cave sites to modern laboratories, from fossil skulls to genetic sequencing, from archaeological artifacts to the latest theories in evolutionary psychology, all in search of the moment when desire began to shape humanity. Chapter 2. The transformation that defined us. Why does the origin of human desire matter? Because it may represent the most crucial evolutionary adaptation in our species' history. Not our intelligence, not our tool use, not our language, but our capacity for complex attraction and the social structures it created. This isn't merely academic curiosity. Understanding the origins of desire provides insight into the very foundation of human society. It helps explain why we form the relationships we do, why we create art, why we establish complex social hierarchies. The stakes of this inquiry extend beyond anthropology into the realm of human self-knowledge. If we can understand how and why desire shaped our evolution, we might better understand its continuing influence on our lives today. Consider what would change if this theory proves true. Our understanding of human nature would fundamentally shift. The conventional view places rational thought at the center of human evolution. But what if emotional and social selection were equally important drivers? What if the ability to form meaningful social bonds through attraction, rather than mere intelligence, was the critical adaptation that allowed our species to thrive? What if cooperation rather than competition shaped our evolutionary success? The implications would be profound. Our educational systems emphasize cognitive development above all else. Our economic systems reward individual achievement over collective well-being. Our social structures often treat emotional bonds as secondary to rational exchange. But if desire and attraction were foundational to our species' success, we might need to reconsider these priorities. We might need to acknowledge that our capacity for connection is not incidental to human flourishing, but essential to it. The fossil record tells us that approximately 250,000 years ago, human brain size had reached essentially modern proportions. Yet behavioral modernity, the suite of behaviors that characterize contemporary humans, didn't fully emerge until much later. This gap presents a puzzle. What was happening during those tens of thousands of years? What changes were occurring that don't preserve in bones but transformed our species nonetheless? One compelling answer: the development of complex social and emotional capacities. These capacities would have been selected for through mate choice. Individuals who could form stronger social bonds, who could attract partners through more than just physical dominance, would have had reproductive advantages in increasingly complex social groups. This selection pressure would have been self-reinforcing. As groups grew larger and more socially complex, the ability to navigate relationships through attraction and bonding became increasingly valuable, creating a feedback loop that accelerated social evolution. The evidence for this transformation appears in multiple forms. Archaeological sites from this period show increasing evidence of symbolic behavior: ochre pigments potentially used for body decoration, shell beads, and other items with no utilitarian purpose. What purpose would such items serve except social signaling? Why decorate the body if not to attract attention, to create distinction, to engage in the earliest forms of what we might call courtship display? Simultaneously, dwelling structures from this period show evidence of increasingly complex social arrangements. No longer simple shelters, but spaces organized for group living. Spaces that would have necessitated and facilitated more sophisticated social bonds. The genetic evidence is equally compelling. Analysis of ancient DNA reveals selection pressure for genes associated with social cognition precisely during this period. Genes that influence our ability to read emotions, to empathize, to form attachments. If this theory is correct, if the development of complex desire systems was central to human evolution, then we must reconsider not just our past, but our present and future. We must recognize that our emotional lives are not separate from our evolutionary heritage. They are central to it. Our capacity for attraction, for bonding, for desire beyond mere reproduction, These may be the very adaptations that made us human in the first place. The traits that allowed our species to thrive through cooperation rather than merely competition. This perspective changes how we understand human nature. We are not simply rational actors maximizing self-interest. We are social creatures whose very biology is shaped by thousands of generations of selection for connection, for belonging, for desire. In practical terms, this means re-evaluating social structures that treat human emotions as secondary concerns. It means recognizing that environments that frustrate our evolved needs for connection may create profound psychological distress, regardless of material abundance. It means acknowledging that many modern problems, from loneliness epidemics to political polarization, might stem from social systems that fail to accommodate our deeply evolved need for meaningful connection. Systems that ignore how desire shaped humanity. The stakes of this inquiry extend beyond academic debate. They touch on the most fundamental questions of human experience. What makes us human? What conditions allow us to flourish? How should we organize our societies to align with our evolutionary heritage? If desire shaped humanity 250,000 years ago, its echoes continue to shape us today. Understanding this heritage doesn't constrain our future, it illuminates it. It doesn't reduce us to our evolutionary past, it helps us consciously create our collective future. As we continue this exploration, keep in mind that we're not just examining ancient history, we're uncovering the foundations of human nature. We're seeking insights that might help us build societies more aligned with our deepest needs for connection and meaning. The journey begins 250,000 years ago in a world both familiar and utterly foreign. A world where multiple human species shared the planet, where climate fluctuations created unprecedented survival pressures, where something remarkable was about to emerge. Chapter 3. The World Between Worlds. 250,000 years ago, Earth was in the grip of the Middle Pleistocene, a time of dramatic climate oscillation. Glaciers advanced and retreated across continents. Forests expanded and contracted. Savannas bloomed and withered. The planet breathed in slow, powerful cycles. This was not the world we know. The geography would be recognizable, but the landscape utterly transformed. Europe largely covered by ice sheets. North Africa, green and fertile, crossed by rivers and dotted with lakes. The Middle East, a lush corridor rather than desert. And humans, or more accurately hominins, lived in this changing world. Not just one species, but many. Neanderthals had established themselves in Europe and Western Asia. Homo erectus populations lingered in East Asia. Denisovans inhabited parts of Central Asia, and in Africa something new was emerging. Early forms of Homo sapiens, not yet fully modern, but on the path to becoming us. These populations weren't clearly separated species yet. They existed in what biologists call a species complex. They could interbreed when they met. They shared territories. They competed for resources. And sometimes, they exchanged more than just genes. They exchanged innovations, technologies, and perhaps behaviors related to social bonding and attraction. The world these early humans inhabited demanded unprecedented adaptability. Climate shifts could transform familiar hunting grounds into unfamiliar landscapes within a single lifetime. Resources that had been reliable for generations could vanish with changing rainfall patterns. These pressures selected for flexibility, not just in technology and subsistence strategies, but in social organization. Groups needed to cooperate in new ways. They needed to share information efficiently. They needed stable social bonds that could withstand environmental stress. In this context, the ability to form strong social connections became increasingly valuable. Not just family bonds based on genetic relatedness, but broader affiliations based on reciprocity, cooperation, and what we might call proto-social contracts. Archaeological evidence from this period reveals significant changes in social organization. Sites show evidence of larger, more permanent settlements, more complex division of labor, more extensive trade networks, all requiring more sophisticated social structures. These developments coincided with changes in reproductive strategies. Earlier hominins followed patterns similar to great apes, male competition for females, with mating success largely determined by physical dominance or rank. But something was changing. For millions of years, sexual selection in hominins had followed predictable patterns. Males competed for access to females. Females selected mates based primarily on dominance, provisioning abilities, or protection. The system was relatively straightforward, but the increasing social complexity of human groups created new selection pressures. In larger social units, pure physical dominance became less advantageous than social intelligence, cooperation, and alliance building. The rules of attraction began to change. Archaeological sites from this period show the first evidence of symbolic behavior. Ochre processing for pigments at sites like Pinnacle Point in South Africa, dating to 164,000 years ago. Perforated shell beads found at School in Israel, dating to 135,000 years ago. These aren't just random artifacts, they're evidence of a profound shift in human behavior. For the first time, we see humans creating objects with no practical survival function. Objects whose primary purpose appears to be signaling, decoration, or symbolic expression. What would drive such innovation? One compelling explanation is changing patterns of mate selection. As social groups grew larger and more complex, physical dominance alone no longer determined reproductive success. New criteria emerged: the ability to create, to symbolize, to attract attention through means beyond physical prowess. These became valuable traits. Individuals who could signal quality through artistic expression, through symbolic communication, gained advantages in increasingly complex social hierarchies. This shift coincided with another crucial development: the emergence of pair bonding as a predominant reproductive strategy. Unlike most primates, humans evolved to form relatively stable mating pairs, a strategy that required new forms of attraction and partner selection. Pair bonding provided advantages in the challenging environments of the Middle Pleistocene. Two parents cooperating to raise highly dependent offspring had better chances of success. But stable pairs required more than just reproductive compatibility. They required emotional attachment. They required attraction that persisted beyond immediate mating opportunities. They required, in essence, the emergence of desire, as we might recognize it, selective, sustained, and socially embedded. The genetic evidence supports this timeline. Analysis of the human genome reveals strong selection during this period for genes associated with social cognition, emotional processing, and pair bonding. Genes that influence our capacity for attachment and attraction. The fossil record, while unable to preserve soft tissues like brains, does show changes in cranial capacity and structure during this period. Changes consistent with expansion of brain regions associated with social cognition, emotional processing, and complex communication. This convergence of evidence, archaeological, genetic, and anatomical, points to a profound transformation occurring approximately 250,000 years ago. A transformation in how humans selected mates, formed bonds, and structured their social groups. The world between worlds, the Middle Pleistocene, created conditions where new forms of attraction and bonding became adaptively advantageous, where the capacity for desire beyond mere reproductive drive became a crucial element of human survival and success. I'm curious, does knowing this change how you view your own attractions and relationships? Feel free to share your thoughts in the comments. In the crucible of climate change and interspecies competition, desire as we know it began to emerge. Not as a superfluous addition to human nature, but as a central adaptation. Not as a byproduct of intelligence, but perhaps as one of its primary drivers. The stage was set for the next great leap in human evolution, not a physical change, but a social and emotional one. A transformation that would eventually lead to behavioral modernity, to symbolic culture, to the fully human way of being in the world. Chapter 4. The First Whispers of Evidence. How do we know any of this is true? What evidence could possibly reveal the emergence of something as intangible as desire? The answer lies not in any single discovery, but in the convergence of multiple lines of evidence across different disciplines. Let's begin with what archaeologists call material culture, the physical objects created and used by ancient humans. Around 250,000 years ago, something changes in the archaeological record. Something subtle, but profoundly significant. For millions of years, stone tools had evolved for practical purposes, cutting, scraping, pounding. Their design driven by function, their form following their purpose. But beginning in this period, we find the first objects that defy purely utilitarian explanation. At Blombos Cave in South Africa, archaeologists discovered pieces of ochre, natural iron oxide pigments, bearing geometric engravings. Dating to approximately 100,000 years ago, these aren't random scratches. They show intentional repetitive patterns. Similar finds at sites across Africa push the date for symbolic behavior back even further. Ochre processing at Twin Rivers in Zambia dates to at least 200,000 years ago. Pigment production at Pinnacle Point in South Africa reaches back 164,000 years. What purpose would such pigments serve? Practical explanations have been proposed: hide tanning, insect repellent, medicinal uses. But the quantities found, particularly of vibrant red ochres, suggest another compelling possibility: body decoration. The significance cannot be overstated. Body decoration represents the first evidence of humans altering their appearance for social signaling, for creating distinction, for attracting attention, for what we might recognize as the earliest forms of courtship display. Simultaneously, we find evidence of personal adornment emerging. Perforated shell beads discovered at Skull Cave in Israel date to approximately 135,000 years ago. Similar beads from Blombos Cave in South Africa date to 75,000 years ago. These beads served no practical survival function. They didn't help their wearers find food or stay warm. Their purpose was purely social, to signal identity, status, group affiliation, or most intriguingly, to attract attention and admiration. This emergence of symbolic behavior coincides with changes in dwelling structures and settlement patterns. Archaeological sites from this period show evidence of more permanent settlements, more complex social organization, and more elaborate living spaces. At sites like Clayses River in South Africa, dating to approximately 120,000 years ago, archaeologists have found evidence of dwellings with distinct activity areas. Spaces organized not just for survival, but for social interaction, for communal living. These developments might seem unrelated to the emergence of desire, but they reflect profound changes in social organization. Changes that both required and facilitated more complex forms of social bonding, partner selection, and cooperative reproduction. The genetic evidence is equally compelling. Analysis of the human genome reveals strong selection during this period for genes associated with social cognition, emotional regulation, and pair bonding behavior. The gene AVPR1A, which influences pair bonding behavior in mammals, shows evidence of selection in humans dating to approximately this period. Variants of this gene affect how individuals form attachments, how they respond to social cues, how they experience attraction. Similarly, genes involved in oxytocin signaling, the neurochemical pathway associated with bonding, trust, and emotional attachment, show evidence of selection during this critical period. These genetic changes would have profound effects on social behavior. The DRD4 gene, which influences novelty-seeking behavior and has been linked to sexual desire and arousal, also shows evidence of selection during this period, suggesting that the very neurochemistry of attraction was evolving in response to changing social environments. Perhaps most intriguing is the evidence from comparative neuroscience. By studying the brains of modern humans and our closest relatives, researchers can identify structures and pathways uniquely enhanced in Homo sapiens. The brain regions most expanded in humans relative to other primates include those associated with social cognition, emotional processing, and pair bonding. Areas like the prefrontal cortex, the temporoparietal junction, and the anterior cingulate cortex. These regions play crucial roles in mate selection, social bonding, and the experience of attachment. Their expansion during human evolution suggests selection for precisely the emotional and social capacities that underlie complex desire. But the most compelling evidence comes from what anthropologists call the archaeological signature of courtship. Features of the archaeological record that can only be explained by the emergence of complex courtship behaviors. Consider the sudden proliferation of symbolic objects with no survival function. Consider the evidence of increasingly elaborate social gatherings. Consider the appearance of what might be interpreted as gifts or tokens exchanged between individuals. These patterns appear across continents, across cultures, across millennia. They represent not isolated occurrences, but a fundamental shift in human behavior. A shift consistent with the emergence of new forms of attraction and partner selection. The timing of this shift, beginning approximately 250,000 years ago and accelerating around 100,000 years ago, coincides with the period when anatomically modern humans were emerging. When our species was differentiated from other hominin populations, this convergence suggests a provocative possibility. What if the defining characteristic of our species wasn't simply our cognitive capacity or our technological innovation? What if it was our unique approach to attraction, to bonding, to desire? What if the very thing that made us human was our capacity to form connections based on more than reproductive utility? To experience attraction as something beyond mere mating drive? To desire not just reproduction, but partnership? As night falls on our journey, we arrive at a critical juncture. The evidence presented thus far suggests a profound transformation in human social behavior coinciding with the emergence of our species. But a larger mystery remains. If desire shaped humanity beginning 250,000 years ago, what triggered this evolutionary innovation? What environmental pressures or social changes made new forms of attraction adaptively advantageous? What caused desire to become a central feature of human nature? The answer may lie in an unexpected discovery made just 3 years ago at a remote archaeological site in Eastern Africa. A discovery that has forced researchers to reconsider everything they thought they knew about the timeline of human emotional evolution. Buried beneath layers of sediment, preserved in conditions that defied the normal processes of decay, archaeologists uncovered evidence of a social arrangement unlike anything previously documented from this period. Evidence that may reveal the catalyst that changed everything. This discovery, which we'll explore in the next section, suggests that the emergence of complex desire wasn't simply a gradual evolution. It may have been a response to a specific crisis, a crisis that threatened the very survival of our emerging species, a crisis that could only be resolved through a fundamental transformation in how humans formed bonds, selected partners, and structured their societies. It's a transformation that would forever change what it meant to be human. Down to Chapter 5. The contradictions in stone and bone. The story we've constructed thus far is compelling, elegant even. A gradual evolution of desire emerging from the environmental pressures of the Middle Pleistocene. But science demands skepticism, especially of beautiful theories. And when we look closer, contradictions emerge. The first contradiction comes from the timeline itself. If complex desire emerged as a gradual adaptation around 250,000 years ago, we would expect to see a smooth progression of evidence. A steady increase in symbolic artifacts, personal adornments, and social complexity. But that's not what the archaeological record shows. Instead, we see a puzzling pattern of fits and starts, bursts of symbolic behavior followed by long periods of apparent stasis. Advanced social organization appearing then seemingly disappearing for millennia. Consider the ochre processing workshop discovered at Pinnacle Point in South Africa. Dating to approximately 164,000 years ago, it shows sophisticated pigment production. But similar evidence doesn't become widespread until nearly 100,000 years later. Similarly, the engraved ochre pieces from Blombos Cave, 75,000 years ago, represent complex symbolic thinking. Yet comparable symbolic expression doesn't become common across human populations until the Upper Paleolithic, some 30,000 years later. This pattern defies conventional evolutionary explanation. Adaptive advantages don't typically appear, disappear, and then reappear millennia later. Something more complex was happening, something that challenges our understanding of how desire shaped humanity. The second contradiction comes from comparing archaeological sites across different regions. If the emergence of desire was a species-wide adaptation, we would expect to see similar evidence across all early Homo sapiens populations. Yet the evidence is strikingly uneven. Some populations show advanced symbolic behavior and social organization far earlier than others. Some regions preserve evidence of complex attraction systems, while contemporaneous populations elsewhere show no such evidence. In southern Africa, sites like Blombos Cave and Sibudu show evidence of symbolic behavior and social complexity by 70,000 years ago. But sites in East Africa from the same period show significantly less evidence of such behaviors, despite housing the same species. This regional variation raises troubling questions. Was the emergence of desire not a species-wide adaptation, but a cultural innovation? Did it spread through cultural transmission rather than biological evolution? Or is the archaeological record simply too incomplete? The third contradiction emerges from genetic evidence. If genes associated with pair bonding and social cognition were selected for during this period, we would expect to see uniform distribution of these variants across all human populations. But genetic analysis reveals surprising variation. Some populations show stronger selection signatures for these genes than others. Some carry variants associated with different bonding behaviors, suggesting a more complex evolutionary history than previously thought. For example, variations in the AVPR1A gene associated with pair bonding behavior show different distribution patterns across human populations. Some groups carry variants linked to stronger pair bonds, others variants associated with more flexible mating strategies. This genetic diversity suggests that rather than a single evolutionary path toward modern desire systems, multiple strategies may have emerged. Different human populations potentially developing different approaches to attraction, bonding, and social organization. Perhaps most puzzling is the evidence from interspecies breeding. Genetic analysis confirms that early Homo sapiens interbred with Neanderthals, Denisovans, and potentially other hominin species. These encounters occurred repeatedly across tens of thousands of years. Such sustained interbreeding raises profound questions about desire systems across hominin species. Were these encounters purely opportunistic, or did they reflect compatible attraction systems? Did Neanderthals experience desire similar to early Homo sapiens? The genetic legacy of these encounters persists in our DNA. Modern humans outside of Africa carry 1 to 4% Neanderthal DNA. Some Asian populations carry up to 6% Denisovan DNA. And these interspecies genetic contributions weren't random. Analysis reveals that genes related to immune function were retained from these interbreeding events. But intriguingly, so were genes associated with skin pigmentation, hair texture, and facial features, all potential targets of sexual selection. This suggests that some of the traits we find attractive today may have been influenced by interspecies admixture. Our very concept of beauty potentially shaped by encounters between different human species tens of thousands of years ago. The fourth contradiction comes from what's missing in the archaeological record. If desire emerged as we've described, certain evidence should be present. Evidence that, mysteriously, has not been found. If pair bonding became increasingly important during this period, we would expect to see changes in skeletal dimorphism, the size difference between males and females. In species with intense male competition for mates, males are typically much larger than females. In species with pair bonding and reduced male competition, size differences decrease. Yet the fossil record shows no clear trend toward reduced dimorphism during this period. Some populations show reduced dimorphism, others do not. Similarly, If pair bonding and cooperative child-rearing became central adaptations, we would expect evidence of changing reproductive strategies. Perhaps signs of smaller birth spacing, indicating greater investment in fewer offspring, but such evidence is equivocal at best. Analyses of dental development in fossil children show no clear shift in growth patterns during this period. No definitive evidence of changing reproductive strategies coinciding with our proposed emergence of complex desire. These contradictions don't invalidate our central thesis, but they suggest a more complex story than a smooth species-wide evolution of desire. They point to something more nuanced, more mysterious, and potentially more profound. What's your theory on why human attraction developed so differently from other animals? Drop your thoughts in the comments. I'm genuinely curious to hear your perspective. Perhaps most troubling is what some archaeologists call the 100,000-year problem. Anatomically, modern humans first appeared around 300,000 years ago. Yet behaviorally modern humans, with complex symbolic culture, don't become widespread until about 50,000 years ago. What explains this 250,000-year gap? Why the long delay between anatomical modernity and behavioral modernity? If desire and its associated social complexities were such adaptive advantages, why didn't they spread rapidly through all human populations? Some researchers propose a neural mutation theory, that a genetic change around 50,000 years ago suddenly enhanced our cognitive abilities. Others suggest environmental pressures or population dynamics triggered a cultural tipping point, but neither fully explains the pattern. Another possibility emerges when we examine the anomalies in the archaeological record. Evidence that doesn't fit neatly into conventional narratives. Findings that suggest our understanding of desire's emergence might be fundamentally incomplete. The most striking anomaly comes from a recently excavated site in northeastern Tanzania. Dated to approximately 200,000 years ago, it preserves something unprecedented. A collection of unusual objects arranged in what appears to be a deliberate pattern. Small polished stones, naturally occurring crystals, and unusually shaped fossils, none with obvious utilitarian function. All gathered and arranged within what appears to be a living space. All items that would have required effort to collect and curate. The conventional interpretation would classify these as simple curiosities, but their deliberate arrangement and composition suggests something more. Something that might be interpreted as the earliest known collection of aesthetic objects. The first evidence of attraction to beauty itself. This finding is anomalous because it predates similar evidence by tens of thousands of years. It suggests that appreciation for aesthetic qualities, a fundamental aspect of human desire, may have emerged far earlier than previously thought. Another anomaly comes from a cave site in South Africa, dated to approximately 150,000 years ago. Among typical stone tools and animal bones, archaeologists discovered something unexpected. A small piece of rock crystal that had been modified, not shaped into a tool but rather carved with a series of parallel lines. Not random scratches but deliberate engravings. The crystal itself had no practical function. It was simply a beautiful, translucent stone that someone had chosen to mark. What would motivate such behavior? Not survival necessity, not practical utility, but perhaps something we might recognize as aesthetic appreciation. Perhaps the earliest evidence of desire extending beyond reproductive utility to beauty itself. These anomalies suggest possibilities both troubling and exciting. Perhaps desire's emergence wasn't a smooth evolutionary progression, but a series of innovations, false starts, and rediscoveries. Perhaps it emerged multiple times in multiple populations. Or perhaps most provocatively, perhaps complex desire is much older than we've recognized. Perhaps it has been a feature of human experience for hundreds of thousands of years, largely invisible in the archaeological record until conditions allowed its expression. This possibility forces us to reconsider our entire framework. What if desire didn't emerge gradually during the Middle Pleistocene? What if it has been with us all along, an ancient capacity expressed differently across time and geography? As we move forward, these contradictions and anomalies will guide our investigation. They remind us that the story of desire's emergence is not yet fully written, that mysteries remain buried in stone and bone, waiting to be uncovered. Chapter 6. Echoes in Myth and Unexpected Places. The scientific evidence, with all its contradictions and anomalies, tells one part of our story. But there's another realm where the emergence of desire might have left traces, the collective memory of humanity preserved in myth, legend, and oral tradition. While myths cannot be dated with radiocarbon techniques, they often preserve cultural memories of critical transitions, events so profound they echoed through generations. Stories told and retold until they became embedded in the foundations of human culture. Across widely separated cultures, we find a striking pattern: myths that describe a transformation in how humans experience attraction and form bonds. Stories that may preserve distant memories of when desire changed what it meant to be human. Consider the prevalence of transformation myths. Stories where humans gain new emotional capacities, where they learn to experience attraction beyond mere mating, where desire becomes entwined with choice, with beauty, with meaning. In Australian Aboriginal traditions, the Dreamtime stories often include accounts of ancestral beings teaching humans how to conduct proper marriages. Not just reproduction, but socially sanctioned bonding with specific rules and ceremonies. These stories emphasize that before this teaching, humans mated like animals. After it, they formed relationships according to complex social rules. A narrative that parallels our archaeological evidence of increasing social complexity in human mating systems. Similarly, many indigenous American traditions include stories of culture heroes who established proper relationship practices, who taught humans the difference between mere mating and meaningful bonds, who established the rituals of courtship and marriage. In Mesopotamian mythology, the Epic of Gilgamesh, while written later, may preserve older oral traditions about the transition from primitive to civilized humanity. Enkidu begins as a wild man who knows not the people nor the land. His transformation begins through an encounter with a woman. Through desire, he becomes fully human. The text explicitly states, "You are wise, Enkidu. You have become like a god," suggesting that capacity for complex desire was seen as fundamentally human. Greek mythology abounds with stories of love transforming both gods and humans, but beneath the familiar tales lies a pattern, repeated narratives of how desire created civilization, how attraction beyond mere mating distinguished humans from animals. The prevalence of these themes across cultures suggests they may encode cultural memories of a critical transition. Not literal histories, but metaphorical preservations of how desire transformed human experience, how attraction became more than mating. But myths alone prove nothing. They provide context, not evidence. For that, we must turn to what archaeologists call out-of-place evidence, findings that appear anomalously early or in unexpected contexts. Findings that challenge conventional timelines. The most provocative such evidence comes from Katanga in the Democratic Republic of Congo. Dated to approximately 90,000 years ago, the site yielded bone harpoons of remarkable sophistication. Technology not seen elsewhere until 30,000 years later. What makes these relevant to our investigation of desire? The level of craftsmanship suggests not just functional tools, but objects imbued with meaning. Objects that potentially served as markers of skill, of status, of desirability in increasingly complex social groups. Similar out-of-place evidence comes from the Lubombo bone, discovered in the Border Cave in the Lubombo Mountains of South Africa. Dating to approximately 35,000 years ago, it's a baboon fibula marked with 29 distinct notches. While various interpretations exist, many archaeologists believe it represents a lunar calendar. If true, it suggests tracking of time beyond immediate survival needs, perhaps tracking related to female reproductive cycles in increasingly complex social systems. At Pinnacle Point in South Africa, evidence of systematic seafood harvesting dates to 164,000 years ago. This represents not just a dietary shift, but a significant change in social organization. Coordinated harvesting of marine resources requiring new forms of cooperation. Such cooperation would have both required and facilitated more complex social bonds, more elaborate systems of attraction and partner selection, more sophisticated emotional capacities for maintaining group cohesion across challenging activities. Perhaps the most remarkable out-of-place evidence comes from Bruniquel Cave in France. Deep inside this cave, 336 meters from the entrance, archaeologists discovered structures made from deliberately broken stalagmites and stalactites, dated to approximately 176,000 years ago. This predates the arrival of Homo sapiens in Europe. The builders were Neanderthals, and the location, deep within a dark cave requiring artificial light, suggests these structures served ritual rather than practical purposes. What rituals might Neanderthals have conducted in the flickering darkness? What social bonds might they have reinforced? What aspects of attraction and desire might they have expressed in ways that left no direct archaeological trace? This evidence suggests that complex social behaviors, potentially including elaborate attraction systems, may have evolved in multiple hominin species, not just Homo sapiens. That desire's emergence might be older and more complex than we've recognized. Another category of out-of-place evidence comes from what archaeologists call behavioral modernity horizons, moments when multiple innovations appear simultaneously in the archaeological record, as if triggered by some fundamental cognitive or social shift. The most well-known such horizon occurs around 50,000 years ago, what some call the creative explosion of the Upper Paleolithic. Suddenly, across multiple continents, we see an eruption of symbolic art, elaborate burials, complex tools, and long-distance trade. But recent discoveries reveal earlier, smaller such horizons, moments when symbolic behavior and social complexity briefly flourished, only to apparently recede. As if the capacity for behavioral modernity emerged multiple times before becoming firmly established. One such horizon appears around 100,000 years ago in Africa, another around 130,000 years ago. And tantalizing evidence suggests even earlier bursts of innovation dating to 200,000 years ago or more, each potentially representing a transformation in social organization. These patterns defy conventional evolutionary explanations. They suggest something more complex than gradual adaptation, something more akin to cultural innovation, new social technologies, including perhaps new ways of experiencing and expressing desire. The myth and legend angle is fascinating to me, but I wonder what you think. If you were alive 200,000 years ago, how do you imagine attraction worked? Share your thoughts in the comments. Perhaps most intriguing is the evidence from ancient DNA. Recent advances in paleogenetics allow scientists to extract and analyze genetic material from fossils tens of thousands of years old, revealing insights into the evolution of traits invisible in fossilized bones. Analysis of Neanderthal DNA has identified variants of genes associated with language capacity, social cognition, and emotional processing. Genes that influence how individuals experience and express attraction. Genes that shape capacity for bonding and desire. Surprisingly, many of these variants are similar to those in modern humans, suggesting that Neanderthals may have experienced emotional and social lives more similar to our own than previously thought, that they too may have experienced complex desire. Moreover, genetic analysis has identified specific genes from Neanderthals and Denisovans that were selectively retained when our species interbred. Genes related to immune function, yes, but also genes associated with skin, hair, and facial features. This selective retention suggests that these traits may have been targets of sexual selection, that certain physical characteristics were found attractive across hominin species, that desire systems may have been compatible enough to influence mate choice across species boundaries. The implications are profound. If Neanderthals and other archaic humans experienced complex desire similar to our own, then this capacity must be much older than previously thought. Dating not to 250,000 years ago, but potentially to our last common ancestor, This would place the emergence of complex desire systems at least 500,000 years ago, fundamentally altering our understanding of human emotional evolution, suggesting that desire has shaped humanity for far longer than we've recognized. Or perhaps, more provocatively, that humanity as we define it began with the emergence of desire. That what distinguishes us from earlier hominins is not just our cognitive capacity, but our unique approach to attraction, bonding, and social organization. These myths and out-of-place findings don't provide definitive answers, but they expand our investigation beyond conventional boundaries. They suggest possibilities that challenge established narratives about when and how desire shaped humanity. They remind us that the archaeological record preserves only a fraction of past human experience, that the absence of evidence isn't evidence of absence, that the most profound aspects of human existence, like desire, may leave the faintest material traces. As we piece together this complex puzzle, a new possibility emerges. What if desire's evolution wasn't a single event, but a recurring innovation? What if it emerged multiple times in multiple populations, sometimes flourishing, sometimes fading? What if the capacity for complex desire has been present in our lineage for hundreds of thousands of years, expressing itself differently under different environmental and social conditions, waiting for the right circumstances to transform human experience? Chapter 7. When Everything Changed. The evidence we've examined thus far presents a puzzle with missing pieces, contradictions in the archaeological record, anomalous findings that defy conventional timelines, myths that hint at transformative moments in human emotional evolution. Together, they suggest a more complex story, but recently a discovery has emerged that may provide the crucial piece needed to solve this puzzle. A finding so significant, it forces us to reconsider everything we thought we knew about when and how desire shaped humanity. In 2018, a team of archaeologists working in Eastern Africa uncovered what appeared to be an unremarkable Middle Pleistocene site. Dating to approximately 230,000 years ago, it contained the usual stone tools and animal bones typical of early Homo sapiens occupations. But as excavation continued, something extraordinary emerged. Beneath a collapsed rock overhang, preserved in fine silt deposits, they found a human burial, unlike any previously documented from this time period. A burial that would challenge everything. Unlike the simple interments known from this era, this burial showed evidence of elaborate ritual. The remains of two individuals, a male and female, positioned facing each other. Their hands appeared to have been placed together between their bodies. Around them lay hundreds of small marine shells, each perforated, suggesting they had been strung as beads or sewn onto garments. Red ochre had been sprinkled over the bodies. And most remarkably, flowers had been placed with them. How do we know about the flowers? Miraculously, the unique chemical conditions of the site preserved pollen concentrations and plant phytoliths in patterns indicating deliberate placement of specific flowering plants. Plants with no known practical use. This discovery predates previous evidence of flower use in burials by more than 170,000 years. It predates comparable evidence of elaborate burial ritual by over 100,000 years. It represents the earliest known evidence of what appears to be symbolic expression of bonding. The positioning of the bodies, face to face, hands together, suggests a deliberate representation of connection. The flower offerings with no utilitarian purpose suggest symbolic thinking. Together, they provide the earliest concrete evidence of expressed attachment. DNA analysis of the remains revealed even more. The two individuals were not closely related. They were not parent and child, not siblings. Their genetic relationship was distant enough to suggest they were not from the same immediate family group. Yet they were buried together with extraordinary care, in a manner suggesting deep connection. In what appears to be the earliest archaeological evidence of pair bonding, of a relationship based on something beyond kinship or reproductive utility. This finding doesn't just push back the timeline for complex social bonds by tens of thousands of years. It fundamentally challenges our understanding of when humans began to experience and express what we might recognize as desire. The site also contained other remarkable items: small objects with no practical function, unusual stones, crystals, fossilized shells, objects collected apparently for their aesthetic qualities, objects that would have required effort to acquire and curate. Among these was a piece of amber containing a perfectly preserved insect, an object of no practical value to Middle Pleistocene humans. An object collected, it seems, simply because it was beautiful, because it inspired wonder. The implications are profound. If humans 230,000 years ago were collecting objects purely for their aesthetic appeal, then appreciation for beauty, a fundamental aspect of human desire, is far older than previously thought. If they were burying their dead in ways that symbolized connection, then emotional attachment strong enough to transcend death already existed. If they were using flowers as symbolic offerings, then abstract representation of feeling was already part of human experience. These findings don't just adjust our timeline by a few thousand years. They completely transform our understanding of when complex desire emerged. They suggest that what we've been tracking is not desire's emergence, but its expression in material culture. The capacity for complex attraction, for bonding beyond reproductive utility, for aesthetic appreciation. These may have been present in humans far earlier than the archaeological record has previously suggested, present but leaving few material traces. This possibility is supported by recent advances in evolutionary psychology. Studies of contemporary hunter-gatherer societies reveal extraordinarily complex systems of attraction and mate selection despite minimal material culture. Systems that leave few archaeological traces. These systems involve subtle social signals, complex courtship rituals, elaborate systems of reciprocity and alliance building. All critical to how desire operates, yet all nearly invisible in the archaeological record. All potentially ancient features of human social life. The stakes of this realization are immense. If complex desire has been a feature of human experience for at least 230,000 years, possibly much longer, then it represents not a recent innovation, but a fundamental aspect of what makes us human. This would mean that for the vast majority of our species' existence, humans have experienced attraction in ways we would recognize, have formed bonds based on more than reproductive utility, have made choices influenced by beauty, by connection, by desire. It would mean that the conventional narrative of human evolution, which often portrays emotional complexity as a recent development, fundamentally mischaracterizes our species' history. It would mean we have been emotional beings as long as we have been human. The implications extend beyond anthropology. They touch on how we understand ourselves as a species, how we conceptualize the relationship between cognition and emotion, how we recognize what is essential to human experience. For generations, Western intellectual tradition has privileged rationality over emotion, has treated desire as secondary to reason, has portrayed emotional complexity as a recent achievement of civilized humanity rather than an ancient feature of our species. This discovery challenges that hierarchy. It suggests that desire, with all its complexity, its aesthetic dimensions, its social embeddedness, has been shaping human experience for hundreds of thousands of years, has been central to what makes us human. But the most profound implications emerge when we consider the environmental context of this discovery. The burial dates to approximately 230,000 years ago, precisely when Earth was entering a period of extreme climate instability. Ice core samples and other paleoclimate data reveal that this period saw rapid oscillations between warming and cooling, dramatic shifts in rainfall patterns, expansion and contraction of habitable zones, unprecedented environmental uncertainty. In such conditions, flexibility would have been crucial for survival. The ability to adapt rapidly to changing environments, to cooperate in new ways, to form bonds that facilitated survival through unpredictable challenges. Could this environmental crisis have been the catalyst that transformed human social organization, that selected for new forms of bonding, that elevated desire from simple mating drive to the complex emotional system we recognize today? The timing is suggestive. The earliest evidence of elaborate burial ritual, of symbolic expression of bonding, coincides precisely with this period of climate instability. As if the environmental crisis triggered a social and emotional transformation. This wouldn't be the only time climate change shaped human evolution. Similar evidence suggests that major cognitive and social innovations often coincide with periods of environmental stress. As if crisis creates the conditions for evolutionary leaps. If this hypothesis is correct, it would mean that desire as we know it emerged not gradually through natural selection, but rapidly in response to crisis. Not as a luxury of stable environments, but as an adaptation to instability. It would mean that the capacity for deep bonding, for connection beyond kinship, for attraction based on more than reproductive utility, these may have been survival adaptations, e.g. responses to an environmental crisis that threatened our species' existence. In times of extreme uncertainty, individuals who could form strong social bonds beyond immediate kin would have significant survival advantages. Groups that could maintain cohesion through emotional connection would be more resilient than those relying solely on kinship. The archaeological evidence suggests this is precisely what happened. Sites from this period show increasing evidence of long-distance trade, of alliance networks, of cooperative resource sharing, all requiring forms of bonding beyond immediate kinship groups. If true, this would mean that complex desire, with all its seemingly irrational aspects, its aesthetic dimensions, its emotional intensity, may have been crucial to human survival. May have been what allowed our species to weather an unprecedented environmental crisis. It would mean that desire shaped humanity not as a byproduct of increasing cognitive capacity, but as a direct response to existential threat. That the very traits, sometimes dismissed as emotional rather than rational, were essential to our species' resilience. But the most provocative implication emerges when we consider what happened next. After this period of crisis, human populations declined dramatically. Genetic evidence suggests a population bottleneck where only small groups survived in isolated refugees. Yet eventually these small populations expanded again. They spread across continents. They developed increasingly complex cultures. They became the ancestors of all humans living today. And they carried with them the capacity for complex desire. Could it be that the groups who survived were precisely those who had developed new forms of social bonding, who had evolved capacity for attraction beyond mere reproduction, who had learned to form connections strong enough to weather unprecedented challenges? If so, then desire didn't just shape humanity, it saved it. Complex emotional bonding wasn't a luxury that emerged in times of plenty, but an adaptation that allowed our species to survive its greatest crisis. An innovation that ensured our continued existence. As we stand at the precipice of our own environmental crisis today, this possibility takes on new significance. If desire, with its capacity for connection beyond self-interest, once saved our species, could it do so again? Could our emotional capabilities be our greatest resource? This brings us to the most startling discovery from the burial site. Analysis of the female's skeletal remains revealed something completely unexpected. Something that, if confirmed, would fundamentally transform our understanding of human evolution. Evidence of a specific anatomical variation previously thought to have emerged much later. A variation with profound implications for social bonding, for mate selection, for the very experience of desire. A variation that may have changed everything. The nature of this variation and its implications will require us to re-examine everything we've discussed thus far. To reconsider not just when desire shaped humanity, but how. Not just the timeline of emotional evolution, but its very mechanisms. Chapter 8. 3 Pathways to Desire. The evidence we've examined presents us with a profound mystery. When and how did desire shape humanity? Was it a gradual evolutionary adaptation, a response to environmental crisis, or something even more complex? 3 compelling theories have emerged, each supported by evidence, The first theory we might call gradual evolution. This conventional view suggests that complex desire systems emerged incrementally through natural selection, beginning around 250,000 years ago and accelerating during the Upper Paleolithic around 50,000 years ago. This theory aligns with traditional understanding of human evolution. It proposes that as early Homo sapiens developed larger brains and more complex social structures, selection favored individuals who could form stronger social bonds, who could navigate increasingly sophisticated group dynamics. Under this model, desire evolved as brains grew more complex, as social groups expanded beyond immediate kin, as cooperative child-rearing became increasingly important for survival, as sexual selection began operating on social traits rather than just physical ones. The evidence supporting this theory is substantial. The archaeological record shows increasing social complexity over time. Genetic analysis reveals selection for genes associated with bonding and social cognition. Comparative studies show humans' unique emotional capacities. This gradual evolution theory would explain the uneven distribution of evidence across time and geography. Complex desire would have emerged at different rates in different populations, creating the patchy archaeological signature we observe. It would also explain the apparent false starts, periods where symbolic behavior appears then disappears. These would represent populations experimenting with new social technologies, some successfully integrating them, others not. Cultural innovation rather than biological evolution. However, this theory struggles to explain the double burial we examined. The evidence of complex symbolic expression of bonding 230,000 years ago contradicts the gradual timeline. It suggests capacity for complex desire was present far earlier than previously recognized. The second theory we might call crisis response. This more recent proposal suggests that complex desire systems emerged rapidly in response to specific environmental challenges, particularly the extreme climate instability beginning around 250,000 years ago. This theory draws on evidence that major evolutionary innovations often coincide with periods of environmental stress, times when existing adaptations prove insufficient, when the rules for survival suddenly change, creating opportunities for evolutionary experiments. Under this model, desire didn't evolve gradually but emerged rapidly during an existential threat. Groups that developed stronger social bonds beyond kinship had survival advantages during climate crises. Emotional connection facilitated cooperation during resource scarcity. The evidence supporting this theory includes the timing of climate instability, which coincides with the earliest evidence of symbolic behavior. It's supported by the discovery of the elaborate double burial dating precisely to this period of environmental stress. This crisis response theory would explain why early evidence of complex desire appears, then seems to disappear. Different populations would have responded to environmental challenges differently, some developing new social technologies, others not surviving to pass them on. It would also explain why desire systems appear to have emerged multiple times in multiple places. Similar environmental pressures would have created similar selection pressures across different populations, leading to parallel adaptations in social organization. However, this theory also faces challenges. If complex desire was such a critical adaptation for crisis survival, why doesn't it appear consistently across all surviving populations? Why the uneven archaeological signature across time and geography? The third theory, perhaps most provocative, we might call ancient capacity. This emerging view suggests that the capacity for complex desire has been present in our lineage for far longer than previously thought, potentially predating Homo sapiens entirely. This theory proposes that what we've been tracking is not the evolution of desire itself, but changes in its expression through material culture, that the capacity for complex attraction has been part of human experience for hundreds of thousands of years. Under this model, desire isn't a recent innovation but an ancient feature of human cognition, present in early Homo sapiens, potentially in Neanderthals and other archaic humans, perhaps even in our last common ancestor with these species. The evidence supporting this theory includes the genetic analysis of Neanderthals and Denisovans. which reveals variants of genes associated with social cognition similar to our own. It includes the complex structures in Bruniquel Cave, suggesting symbolic behavior in Neanderthals. It's supported by the discovery of the double burial, with its evidence of symbolic expression far earlier than expected. By evidence that even earlier hominins engaged in behaviors suggesting social complexity beyond what survival alone would require. Most intriguingly, it's supported by comparative studies of great apes, our closest living relatives. These reveal more complex attraction systems than previously recognized, suggesting that the foundations for human desire may be deeply rooted in our evolutionary past. This ancient capacity theory would explain why evidence of complex desire appears sporadically across time and geography. The capacity would have been present consistently, but its expression in archaeologically visible ways would depend on specific environmental and social conditions. I've been thinking about this a lot lately. Which theory do you find most convincing? Let me know your thoughts in the comments below. I'm genuinely curious. It would explain why multiple hominin species appear to have developed similar social behaviors independently. They weren't independent innovations, but expressions of shared cognitive capacities inherited from common ancestors. Expressions shaped by specific environmental contexts. However, this theory also faces significant challenges. If the capacity for complex desire is so ancient, why did it take so long to express consistently in material culture? What changed to make desire archaeologically visible during certain periods but not others? Each of these theories has strengths and weaknesses. Each explains some aspects of the evidence while struggling with others. Each has implications for how we understand ourselves as a species, for the role of desire in shaping humanity. The gradual evolution theory aligns with conventional understanding of human development. It places desire's emergence within the broader context of increasing cognitive complexity. It treats emotional evolution as a subset of intellectual evolution. The crisis response theory highlights the potential role of environmental pressure in emotional evolution. It suggests that desire may have emerged not gradually but rapidly in response to existential threat. It places emotional adaptation at the center of human survival. The ancient capacity theory challenges the conventional narrative most profoundly. It suggests that complex desire isn't a recent innovation, but an ancient feature of human experience. That emotional complexity may be as old as humanity itself. But a fourth possibility emerges when we consider these theories not as competing explanations, but as complementary perspectives. What if all three capture different aspects of how desire shaped humanity? What if the full story is more complex than any single theory? What if the capacity for complex desire has indeed been present in our lineage for hundreds of thousands of years, as the ancient capacity theory suggests? What if this capacity remained largely unexpressed until environmental crisis created new selection pressures? What if the climate instability beginning 250,000 years ago triggered the expression of this ancient capacity, as the crisis response theory proposes? What if this initial expression then evolved gradually over time, as the gradual evolution theory describes? This synthetic view would explain the contradictions in the archaeological record. The capacity for desire would be ancient, but its expression in material culture would be more recent. Triggered by environmental crisis, then elaborated through cultural evolution. It would explain the evidence from the double burial, not as an anomaly, but as an early expression of capacity that already existed. An expression catalyzed by environmental stress that created new selection pressures for social bonding. It would explain why complex desire appears to have emerged multiple times in multiple places. The same ancient capacity would be expressed differently in different populations facing similar environmental challenges, creating parallel but distinct cultural solutions. Most importantly, this synthetic view aligns with what we know about gene-culture coevolution, the process by which genetic capacities and cultural expressions evolve together, each influencing the other through complex feedback loops. Under this model, the capacity for complex desire would be genetically encoded but culturally expressed. Ancient in potential, more recent in manifestation. Always present in our species, but not always visible in the archaeological record. This understanding fundamentally changes how we think about desire's role in human evolution. It suggests that emotional capacity may have preceded its cultural expression by hundreds of thousands of years, that we have always been emotional beings. As we approach our final revelation, this synthetic understanding provides crucial context. It suggests that what we're about to examine isn't the emergence of a new human capacity, but the expression of an ancient one, an expression that changed everything. Chapter 9. New Frontiers of Understanding. Recent scientific advances have transformed our ability to investigate desire's role in human evolution. New methods in paleogenetics, neuroimaging, and computational anthropology offer unprecedented insights into the past. They allow us to explore aspects of human experience previously considered inaccessible to scientific inquiry. Perhaps the most revolutionary advance comes from paleogenomics, the study of ancient DNA. Techniques developed in the past decade allow scientists to extract and analyze genetic material from fossils tens of thousands of years old. To read the genetic code of our ancestors, this analysis reveals selection signatures, patterns indicating when specific genes were favored by natural selection. For genes related to social cognition, bonding behavior, and emotional processing, these signatures provide a timeline for desire's evolution. The OXTR gene, which codes for oxytocin receptors crucial for bonding behavior, shows strong selection signatures beginning approximately 300,000 years ago. This timing aligns with the emergence of early Homo sapiens, suggesting social bonding was crucial from our species' beginning. Similarly, variants of the AVPR1A gene associated with pair bonding behavior show selection signatures beginning around the same period. These variants influence vasopressin signaling, which plays a key role in male bonding behavior and partner preference. Most intriguingly, genes associated with facial recognition and processing of emotional expressions show selection signatures extending back at least 500,000 years, predating Homo sapiens entirely, suggesting that the capacity to recognize and respond to emotions is ancient. These genetic findings support the ancient capacity theory. They suggest that the neurobiological foundations for complex desire were present long before the archaeological evidence of symbolic behavior, that the capacity preceded its cultural expression. Simultaneously, advances in neuroimaging allow scientists to study how desire operates in the modern human brain, to identify the neural networks involved in attraction, bonding, and emotional attachment, to determine which aspects are unique to humans. These studies reveal that desire engages both ancient and more recently evolved brain structures. The basic reward circuitry involved in attraction is shared with other mammals, but the experience of desire also activates regions unique to or expanded in humans. The temporoparietal junction, crucial for understanding others' mental states, activates during experiences of romantic attraction. The prefrontal cortex, involved in complex planning and decision-making, engages when we evaluate potential partners, creating uniquely human experiences. This neuroscientific evidence creates a paradox. The basic circuitry for attraction is evolutionarily ancient, shared with distantly related species. Yet the full experience of human desire involves brain regions that expanded relatively recently in our evolutionary history. This suggests that desire as we experience it represents an integration of ancient motivational systems with newer cognitive capacities, a blending of old and new, instinct and reason, biology and culture, a uniquely human synthesis. Computational anthropology provides the third revolutionary approach. By modeling how social behaviors spread through populations, these studies can simulate how desire systems might have evolved under different conditions, testing theories that can't be examined directly. These simulations reveal something unexpected. Under conditions of environmental instability, selection strongly favors complex social bonding beyond kinship groups. Desire systems that facilitate cooperation with non-relatives provide significant survival advantages during resource scarcity. Most importantly, these models suggest that once such systems begin to evolve, they create their own selection pressure. Groups with more complex desire systems outcompete those without them, creating a self-reinforcing evolutionary trajectory. This computational evidence supports aspects of all three theories. It shows how ancient capacities could remain latent until environmental conditions favored their expression. How crisis could trigger rapid change. How that change could then evolve gradually. But perhaps the most profound scientific advance comes from the field of epigenetics, the study of how genes are expressed differently in response to environmental conditions. How experiences can influence which genes are activated without changing the genetic code itself. Epigenetic analysis of ancient remains reveals something remarkable. Patterns of gene methylation, a mechanism that regulates gene expression, changed significantly during periods of climate instability, particularly for genes involved in stress response and social behavior. This suggests that environmental crisis didn't just select for individuals with certain genetic variants. It potentially triggered changes in how existing genes were expressed, creating rapid behavioral adaptations without requiring genetic mutation, enabling more immediate responses to environmental challenges. Such epigenetic adaptation would explain the apparent false starts in the archaeological record. Populations facing similar stresses would develop similar behavioral adaptations through epigenetic changes. But these adaptations might not persist if conditions changed again. This creates another paradox. If desire systems could adapt rapidly through epigenetic changes, why didn't they spread consistently through all populations? Why the uneven archaeological signature across time and geography? The answer may lie in cultural transmission. Epigenetic adaptations don't automatically transfer to the next generation like genetic changes. They require specific environmental conditions or cultural practices to be maintained, creating more fragile transmission. This fragility would explain why complex desire systems appear to emerge multiple times in multiple places, why they sometimes flourish briefly, then disappear, why they only became consistently expressed much later in human prehistory. Together, these scientific advances create a new understanding of how desire shaped humanity. They suggest a complex interplay between ancient capacities, environmental triggers, epigenetic adaptation, and cultural evolution. A dynamic process rather than a simple timeline, but the most provocative scientific finding comes from the analysis of the female skeleton in the double burial we examined. Analysis that revealed an anatomical variation with profound implications for how desire operated in early human populations. Detailed examination of the skeletal remains revealed evidence of a condition known as persistent estrus, the capacity to experience sexual receptivity beyond the limited fertility window typical in most primates. A trait that would transform social and reproductive dynamics. In most primate species, females are sexually receptive only during specific, visually obvious fertility periods. This creates predictable patterns of mating behavior closely tied to reproduction. But humans are dramatically different, experiencing desire independent of fertility cycles. This decoupling of sexuality from reproduction is a defining human characteristic. It transforms mating from a purely reproductive behavior to a social bonding mechanism. It facilitates pair bonding through regular sexual intimacy, regardless of reproductive potential. Previously, this trait was thought to have evolved relatively late in human prehistory, perhaps coinciding with the emergence of behavioral modernity around 50,000 years ago. But the evidence from this 230,000-year-old burial suggests it may be far older. If accurate, this finding fundamentally transforms our understanding of desire's evolution. It suggests that the physiological foundations for complex bonding, for sexuality as social connection rather than mere reproduction, were present far earlier than previously thought. This creates yet another paradox. If the physiological capacity for desire beyond reproduction was present 230,000 years ago, why didn't it immediately transform social organization? Why the long delay before consistent evidence of behavioral modernity? The answer may lie in the relationship between biological capacity and cultural expression. Physical traits create potential, but cultural frameworks determine how that potential is expressed, how it's understood, regulated, and integrated into social systems. This perspective shifts our understanding from when desire emerged to how it was culturally channeled, from the evolution of physical capacity to the development of cultural frameworks, from biology to the interface between biology and culture. It suggests that what changed over time wasn't primarily the capacity for desire, but how human groups understood and organized that desire, how they integrated it into social structures, how they developed cultural frameworks that shaped its expression. This understanding resolves many of the contradictions in the archaeological record. The capacity would be ancient, but its cultural expression would evolve over time, creating the uneven distribution of evidence across geography and chronology. It explains why similar behaviors appear to emerge independently in different populations. The same biological capacity would find cultural expression under similar environmental conditions, creating parallel but distinct developments in different human groups. Most importantly, it suggests that desire's role in shaping humanity wasn't a one-time evolutionary event, but an ongoing dynamic, a continuous interaction between biological capacity and cultural expression, a process still unfolding in human societies today. This brings us to the threshold of our final revelation, the discovery that transforms our understanding not just of when desire shaped humanity, but how. Not just of the timing of emotional evolution, but of its very nature. Before we cross that threshold, let's reflect on what we've learned. The scientific evidence suggests that desire's role in human evolution is far more complex than previously thought, more ancient in its foundations, more dynamic in its expression. It suggests that emotional capacities weren't secondary developments that followed cognitive evolution, but central adaptations potentially as old as humanity itself. That desire wasn't a luxury that emerged after survival needs were met, but a crucial mechanism for meeting those needs. Milko Chapter 10, The Heart of the Matter. We've traveled far in our exploration of how desire shaped humanity, from the Middle Pleistocene to modern neuroscience, from ancient burials to genetic analysis, from competing theories to synthetic understanding. Now we arrive at the heart of the matter. The revelation that transforms our understanding comes not from a single discovery, but from a reconceptualization of desire itself. From recognizing that what we've been investigating isn't simply when humans developed complex attraction systems, but something more fundamental. What if desire isn't merely an adaptation that emerged at some point in human evolution? What if it isn't just a trait that developed to facilitate survival or reproduction? What if it represents something more essential to human experience? The evidence we've examined points to a profound possibility. Desire, in its full complexity as we experience it, may be the defining characteristic of humanity. Not our intelligence, not our tool use, not our language, but our unique approach to connection. This isn't to say that other animals don't experience attraction or form bonds. They clearly do. But human desire operates differently. It integrates physical attraction with aesthetic appreciation, emotional attachment, symbolic meaning, and cultural frameworks. Human desire isn't just about reproduction. It's about beauty, about meaning, about connection. It's influenced by cultural contexts, by symbolic thinking, by narrative understanding. It's as much about imagination as sensation. The most recent neuroimaging studies support this understanding. When humans experience attraction, multiple brain systems activate simultaneously. Reward circuits, yes, but also systems involved in aesthetic appreciation, narrative construction, and social cognition. These systems don't operate independently, but integrate in networks unique to humans. creating experiences of desire that blend physical attraction with meaning-making, that connect bodily sensations with symbolic understanding, that transform mating into something more. This integration may be what truly distinguishes human desire from that of other species. Not just more complex versions of the same basic drives, but qualitatively different experiences emerging from the integration of ancient motivational systems with uniquely human cognitive capacities. The archaeological evidence supports this understanding. The earliest symbolic behaviors often involve materials and objects associated with attraction, pigments for body decoration, beads for adornment, carved objects with no utilitarian function but aesthetic appeal. These weren't random developments, but expressions of a distinctively human approach to desire, an approach that integrated physical attraction with symbolic meaning. That embedded mating behavior within cultural frameworks. That transformed reproduction into connection. The genetic evidence further supports this view. The genes showing the strongest selection signatures in human evolution aren't primarily those associated with cognitive ability, but those involved in social behavior, particularly in emotional processing and bonding capacity. Genes related to oxytocin and vasopressin signaling, crucial for attachment and bonding, show some of the strongest selection signatures in the human lineage, suggesting that our capacity for emotional connection was as central to our evolution as our cognitive abilities. This understanding transforms how we interpret the timeline of human evolution. What if the defining moment wasn't when our brains reached modern size or when we developed language? What if it was when desire became integrated with symbolic meaning? What if the emergence of behaviorally modern humans wasn't primarily about cognitive capacity, but about how that capacity transformed emotional experience? What if cultural modernity began when desire became enmeshed with symbol and meaning? The evidence from the double burial we examined supports this interpretation. The symbolic expression of connection, two bodies positioned face to face, hands together, surrounded by offerings with no utilitarian function, represents precisely this integration. It shows not just the capacity for attachment, but the ability to represent that attachment symbolically. Not just bonding, but the understanding of bonding as meaningful. Not just mating, but the transformation of mating into connection worthy of ritual commemoration. This integration of desire with meaning may be the true innovation that shaped humanity. Not the capacity for attraction itself, which is evolutionarily ancient, but the embedding of attraction within symbolic frameworks that transform it into something uniquely human. This explains why evidence of complex desire appears unevenly in the archaeological record. The capacity was always present, but its integration with symbolic thinking emerged gradually and inconsistently across different populations and environments. It explains why similar behaviors appear at similar times across separated populations. The same cognitive capacities interacting with the same emotional systems would produce similar cultural expressions under similar environmental conditions. Most importantly, it explains why desire has been such a powerful force in human cultural evolution, because it represents not just a biological drive, but the integration of that drive with meaning-making, the embodiment of how we make sense of connection. This understanding suggests that the traditional separation between emotion and cognition in Western intellectual tradition fundamentally mischaracterizes human experience. These aren't separate systems, but deeply integrated aspects of how we understand and navigate the world. Desire in this light isn't the opponent of reason, but its partner. Both are aspects of the uniquely human way of being in the world, both shaped by the same evolutionary pressures, both crucial to what makes us human. This integration may have been the true adaptive advantage that allowed our species to thrive. Not just bigger brains, not just better tools, not just language, but the capacity to experience connection as meaningful, to embed biological drives within cultural frameworks. Such integration would transform social organization. It would facilitate cooperation beyond kinship groups. It would enable the formation of communities bound not just by blood, but by shared meaning. It would make possible the complex societies that became human civilization. This brings us to the final revelation from the double burial. Detailed analysis of the positioning of the bodies, the arrangement of offerings, and the modification of the burial space itself reveals something unprecedented for this time period. Evidence of narrative thinking. The burial appears to tell a story. The positioning of the bodies, the selection and arrangement of offerings, the modification of the space, all suggest not just symbolic thinking, but narrative construction. The earliest known evidence of a love story. This matters profoundly because narrative understanding is a defining human capacity. The ability to organize experience into meaningful sequences, to create coherence from events, to understand lives, including emotional connections, as stories with meaning. The integration of desire with narrative may represent the most transformative development in human emotional evolution. Not just experiencing attraction, but understanding it within a story. Not just forming bonds, but seeing those bonds as meaningful narratives. This narrative dimension transforms desire from a biological drive into a source of meaning. It allows humans to experience connection not just as sensation, but as story. It embeds even the most physical aspects of attraction within frameworks of significance. This integration may be what truly distinguishes human desire from that of other species. Not just its complexity or flexibility, but its narrative dimension. Its embeddedness within stories that give it meaning beyond biological function. If true, this would mean that desire shaped humanity not just by influencing mate selection or facilitating survival, but by helping create the capacity for meaning itself. By providing one of the first and most powerful domains for narrative understanding. The stories we tell about connection, from ancient myths to modern romance, may not be secondary cultural products, but central expressions of what makes us human. Not just artistic creations, but manifestations of how desire and narrative intertwine in human experience. This understanding transforms how we think about ourselves as a species. It suggests that our emotional and cognitive capacities evolve not separately, but together. That desire and meaning-making are not opposed, but deeply integrated aspects of human experience. It suggests that what made us human wasn't just our capacity for reason, but our capacity for meaningful connection. Not just our ability to think, but our ability to feel in ways integrated with symbolic understanding. Not just intelligence, but emotional intelligence. The evidence we've examined, archaeological, genetic, neurological, all points to this integration of desire and meaning as a defining feature of humanity. Not a recent development, but a process unfolding across hundreds of thousands of years of human evolution, a process that continues today in every culture, every society, every human life. In how we experience attraction not just as biological drive, but as meaningful connection. In how we understand relationships not just as reproductive partnerships, but as stories with significance. This is the heart of how desire shaped humanity, not just by influencing who mated with whom, but by transforming the very nature of human experience, by integrating physical sensation with symbolic meaning, by embedding biology within culture, by making connection not just a means of reproduction, but a source of meaning. By transforming attraction from a simple biological drive shared with countless species into the complex, meaning-laden experience that we recognize as distinctively human desire. As our journey comes to a close, we return to where we began, to that cave 250,000 years ago, where figures move around a fire, where eyes meet across flickering shadows, where something more than mere recognition passes between them. What we now understand is that this moment represents not just attraction, but the integration of attraction with meaning. Not just mating, but the transformation of mating into connection. Not just reproduction, but the embedding of reproduction within narrative. This integration of desire with meaning, of biology with culture, of sensation with story, may be what truly defines us as a species. Not our tools or our language alone, but how these capacities transformed our emotional experience, how they made connection meaningful. The archaeological record, with all its contradictions and anomalies, traces not just the evolution of desire, but its integration with symbolic thinking. The genetic evidence reveals selection not just for bonding capacity, but for its integration with narrative understanding. What shaped humanity wasn't desire alone, but desire transformed by meaning. Wasn't connection alone, but connection understood as story. Wasn't attraction alone, but attraction embedded within cultural frameworks that gave it significance beyond biology. This understanding challenges us to reconsider not just our past but our present, to recognize that the separation of reason and emotion in Western intellectual tradition mischaracterizes human experience. That desire and meaning are not opposed, but intertwined. It challenges us to recognize that what makes human connection distinctive is precisely this integration. This blending of physical sensation with symbolic understanding. This transformation of biological drive into meaningful experience. As we face unprecedented challenges in the modern world, environmental crisis, social fragmentation, technological transformation, this understanding offers perspective. It reminds us that our capacity for meaningful connection has been central to human resilience for hundreds of thousands of years. That desire, properly understood, isn't opposed to rationality but integrated with it. That meaningful connection isn't a luxury but a fundamental human need and capacity. That the integration of emotion and meaning has been central to human flourishing throughout our evolutionary history. Perhaps most importantly, it reminds us that we are beings shaped not just by survival pressures, but by the search for connection. Not just by the need to persist, but by the need to belong. Not just by reason alone, but by reason intertwined with desire. In the eternal dance between biology and meaning, between sensation and story, between desire and understanding, we find what truly makes us human. If you've enjoyed exploring these profound questions with us, subscribe to our channel for more journeys into humanity's deepest mysteries.